Okay, we are live. All right. Hello, everyone. My name is Akash. This is my first ever live stream. Uh, so, what am I going to do? This is going to be mostly a coding stream, uh, but we'll see. We'll find out more stuff to do. Uh, I'm interested in a lot of things. I like music, I like coding, I like sports. Um, the main motivation to do this is mainly to try something new and also to code more. I don't get to code a lot in my day job, so this is a way for me to get better at coding and hopefully keep learning. And I want to share my learning with more people, I guess. So, what are we going to do today? So, today is going to be a bit of fun and bit of, I guess, serious work. Um, if you don't know what Advent of Code is, I'm going to be doing that. And to give you some context on what Advent of Code is, it's these series of puzzles released by this guy I don't remember the name of every year in December. And I actually started doing Advent of Code just last year, and it has been a way for me to keep learning new things. And if I don't have anything in my mind what I want to do, I just open up an Advent of Code puzzle and just do that. Um, they tend to be sometimes easy and sometimes ridiculously difficult. Uh, we're going to do something easy today, so I don't want to embarrass myself on my first stream. So yeah, so we'll do some Advent of Code. Uh, and it also kind of maybe gives us a way to get better at Advent of Code before the new one comes this December, which is just 3-4 months out. Uh, okay, what else? We are also going to be working on compilers. I don't know. Uh, I did this compilers course in March, where I built a compiler entirely in Python. It was a pretty simple compiler, not much complexity to it. Uh, but since the past few months, actually, I've been trying to rewrite that compiler in Rust. Um, yeah, so Rust is also a big thing for me right now. I'm trying to learn Rust, get good at Rust. Um, yeah, so today specifically, we are going to be writing the parser for the compiler. Um, I've actually built out quite a few stuff for the compiler already, which I'll give you a walkthrough of, and then we'll write the compiler parser, or at least try to write the compiler parser. I'm really bad at coding fast or in front of people, so we'll see how it goes. Anyway, let's start our first stream ever then. Okay, so is what are we going to do for Advent Code? I was thinking let's start a new year, which is 2018. I've not done any of it, so we'll try to keep progressing in 2018 and try to every stream or maybe some every other stream we'll try to do one puzzle and try to finish this before the December challenge, the 2024 challenge. Um, okay, so let's start. Let's get started. Cool. So yeah, I don't have code. The first puzzle, I think the first part they just explain what are the rules. Is essentially you have to collect 50 stars. Each puzzle has 2 stars because there are like 2 parts to it. the first puzzle is the first thing you see is the part 1, and once you do the part 1 they give you the part 2. So it says each puzzle grants 1 star, every day has 2 puzzles. I think the main puzzle starts here. So after feeling like you have been falling for a few minutes, you look at the device's tiny screen. Device blah blah blah. Below the message, the device shows a sequence of changes in frequency. Frequency is a puzzle input. A value like +6 means current frequency increases by 6. Fair enough. A value like -3 means current frequency decreases by 3. For example, if the display displays frequency changes of +1, -2, +3. Okay, so I guess it just means that the input will be C. We just do the mathematical addition or subtraction accordingly. Okay. Okay, and we start with 0, starting from frequency of 0. Starting with the frequency of 0, what is the resulting frequency after all the changes in frequency have been applied? Okay. Let me just quickly check my audio. Okay, just doing some mic checking. Is it good? Mic is checking. Okay, I think we can start. So yeah, for this I think we're just going to read the input. The input, I imagine, yeah. So it's just a bunch of plus minus numbers. The idea is that we'll just read the input and parse it into an integer, and then just to apply that to the starting frequency of 0. Okay. Let's copy the input and put it into our day thing. Okay. This is some template I just copied from the internet. I think what I'm gonna do is I'm just gonna add a day01.txt. Okay, day01. There's going to be 2 parts, as I said, so there's like 2 solutions for you. Right now we're just concerned with solution 1. So let's do fn part 1. We're just gonna read the input, which is read to string. I'm directly reading everything into memory since the input is not that huge. Otherwise, we would use something like a buffered reader or a normal file reader. But this just basically creates a static string. Input day01.txt, and we just unwrap it. We don't care about proper error handling or anything like that. Let's go Zen mode actually. Hopefully this looks okay. I'm gonna zoom it out a bit. Okay. So we have the string and we know the inputs are in every new line. So let's split that too. Let frequencies be a vector, which we do string, sorry, input dot split does this split automatically by a new line, or is there a new line thing? Lines, oh yeah, there is lines, okay, my bad. And I think this gives us an iterator. Okay. And then for part 1, should we also do this? Map l.parse.unwrap collect. We want to collect to a vec of I size maybe. Wait, what is wrong in this? Cool. So I think this is going to iterate through the lines, parse it. Okay. And for this, we just need frequencies, which is a vec of I size. And this gives us an U64, or I mean, let's just wait. Why is this a U64? Okay. I think we need to. Oh yeah, this needs to be I size. Okay. And yeah, one cool thing I'm using for this is I'm using the cursor IDE, the new AI IDE. I don't really use the autocomplete feature much, but I do use the chatting feature, which I mainly just like try to ask questions about the code. For example, what I do is like sometimes just select the line and then ask it something. Maybe this is like, is this the most efficient way of doing this? Something like this. Okay. I'm gonna have to copy a key, so just give me 1 second. I don't want to show my key here. So I'm gonna hide this for a second. Yeah, so what I found is like having just the chat. I'll actually probably talk about this more some other day, but having a chat alongside your code where you can directly ask them questions is super helpful. And however, I like hate doing the autocomplete, the co-pilot, I guess, because it just like means that I'm not really actually writing a lot of code. um, yeah, so let's add some funds. Okay. um, yeah, so I'll talk more about it different stream, maybe like how I use AI in my coding. uh, but I'll definitely show some things I do here as well. But yeah, so I don't use the autocomplete thing, but I do use the chat, and that has been, I would say, helpful. So let's see if this works now. Is the most efficient way to do this? I don't know why I keep asking chat about this, like how to do something more efficiently. It's just something like I have been doing more and more, especially with the Rust code. Um, Interesting. What is this? It's saying it's. Oh, I don't want to. I don't want to filter it. So I guess we are right. If if something can't be passed into an iSize, we do want to panic. Actually, I don't want to filter it out. Cool. So that's good. What else? Uh, okay. So I guess we just have to add or subtract the frequencies starting from 0. Let's do start frequency. I'm still not really actually like well versed with Rust, so you might see me stumble a lot, but that's okay. Eventually, we'll get good at it. I don't know. It's kind of weird to do it live in front of someone. I tend to just think a lot in my head whenever I'm coding, and I'm having to like say to myself that I need to be speaking out a lot of my thoughts. Yeah, but we'll see. Okay, so this is pretty simple, I think. um, we need this to be I'm just gonna maybe clone this. Or, I mean, I don't need a clone. I can just take it. Native types are, I think, implement clone and copy. So I'm gonna, but however, make this mutable because we want to mutate it. And for frequencies, I'm just gonna iter over it into iter. What is this issue? Type and let's try to run cargo check on this. Oh, it just basically doesn't know. I'm sure there's some other iterator function I can use to do this. Let's see if what Claude says about this. Is there a better way to do this? Oh, that's convenient. So does it start frequency plus frequencies dot iter dot sum. Oh, it needs this. Oh, cool. So basically we are iterating over the frequencies and then summing it all up. Sums the elements of an iterator. Interesting. Okay, so our solution 1 is part 1. Cool. Let's try to cargo run day 1. $590. Okay, let's see if 590 is correct. Oh my god, I've not been sharing my screen. My bad. Damn it. Okay. So since as I said, first ever stream, doing no mistakes. So what I did was for part one, I'm just sending over the frequencies here, and sending over the frequencies here, then iterating over the frequencies, and then uh, just summing it all up and then adding it to our starting frequency, which is, at least for part one, it's 0. And the answer was 590. So I guess part one is done. Let's go to part two. Okay. What is part two? You notice that the device repeats the same frequency change list over and over. To calculate, you need to find the first frequency it reaches twice. For example, using the same list over, the device would loop as follows: current frequency 0, changes of y plus 1, resulting frequency. Okay, this one device continues from the start of the list. Wait, what does this mean? Oh, okay. Oh, we loop over it. Interesting. In this example, the first frequency reached twice is 2. Note that your device might need to repeat its list of frequency changes many times before a duplicate frequency is found. Okay, and that duplicates might be found while in the middle of the processing list. Here are the other examples. What is the first frequency your device reaches twice? Okay, so essentially what we have to do is keep doing this until we find a frequency. Keep adding the new frequencies until we find a frequency which is been already seen. I mean, we can keep a hash set. Let's see. I guess we can't use the iterator here because we want to. We don't want to consume the entire. We just want to keep repeating it. Okay. Let's see. Part 2. Start frequency. And we want to return the frequency we see twice. Return the frequency we encounter twice the first. Okay. So just loop over it. Let frequency set. Let's create a set. Is that a hash set? Yeah, that is. What is an example of a hash set? Let mute frequency set equals to hash set dot new I think we just need to specify the type. I don't know how to do that. Let's just ask our buddy Cloud to do that. Okay. Oh, my bad. Hash set. What is this? Okay. So we're just gonna keep going while let mute current frequency is I size is equal to 0 while um while let oh is none. Okay. uh this is one thing I don't really like about, actually I don't know if I like it or not, but right now I don't like it. Is this like 5 different ways to do something in Rust? Why couldn't I have just done what I had done before? Why did Rust Analyzer just poke its nasty head and say, oh, please use is none? Anyway, what is this? Unnecessary get unnecessary. I feel like it's pretty necessary. Okay, let's see how it goes. Is none. How do I keep looping over frequency? One way is I can just like keep an index and keep incrementing, and if it's reaches the length of the frequencies, I can just reset it to 0. Is there a better way to do it? Okay, let's write it. This is also one more thing which I've been recently trying to adopt is while writing code or any document, I just say to myself that this is going to be a garbage code and I have to rewrite it again from scratch. So that kind of gives me the permission to just write shitty code, at least in the first try, and then we'll try to optimize it. Okay, so what is it? Let mute index equals to 0. Okay. Current frequency, we update it by current frequency plus frequencies dot get index. There's so many linting errors. We'll see how we can fix it later. For now, let's just keep going. Okay. And then we also want to store it in our frequency set. Frequency set dot push add. Okay. And then if current frequency is equal to length frequencies dot length, then current frequency we reset it to 0. Else current frequency is we increment it by 1. Now if index is this, then index this, index this. And when this guy stops, we just return frequency. Let's see if this works. Okay, we have to clone this here. Those of you who don't know, Rust doesn't allow you to because of Rust's borrow checker, when you move frequencies into a function, into another function, you can't, like, at this point when there was no clone here, frequency was gone. Frequency was part of part 1, so we have to clone it and send so that we can use frequencies again in here. Actually, I'm curious why. Because we are not working with references. So what exactly is Rust preventing by not letting us use frequencies twice? Let's ask Mr. Claude. Why doesn't Rust allow me to move frequencies and then use it again later? Yeah, but what is the purpose of that? Hopefully you guys are also learning something. I tend to go on these tangents when I'm coding also sometimes, where I just get interested in something and just try to learn about that. Use after free. Use after free. Okay, so what it is saying is expand on. I'm guessing what it says is if we move it to the function and then we try to drop the variable here, then there will be a data is in part 1. Expand on memory safety, please. Please? I don't know why I'm saying please. Let's say with an example. Nobody's reading that much. Use my code as an example. Deallocated by what exactly? When frequency is passed to part 1 without borrowing, ownership of frequency is transferred to part 1. After part 1 finishes, the frequencies vector would be drawn. Okay, anyway, Rust's borrow checker, I'm still struggling with Rust's borrow checker sometimes, but that's okay. Let's try to run our code. Oh, 9. I doubt 9 is the answer, but that is not the right answer. So what are we doing incorrectly? What we're doing is we are looping until our frequency set, as long as the current frequency is not present in our frequency set. Then we are adding frequency. Oh, it should be length -1 actually. Oh, by 1. Okay, let's try to run it. 9 again. Wait, is it some new? Oh, input hasn't changed though. So this should work. What am I doing wrong? In the hash set, I add the frequency, then Let's ask our friend here. What am I doing wrong here? What are you? You're inserting the reference into the set after checking if it exists. Frequency that appears immediately after the first, not the first. Wait, what do you mean? I guess there's a way to cycle. For what was I doing here? You're inserting the new frequency into the set after checking if it exists. Maybe I'm missing something. I'm too dumb to understand what I'm doing wrong, but let's play something else. This is fine. I don't need to keep this index anymore. And I'm guessing I'm just okay. Wait, insert will fail. Why does insert fail? If the set already false. This is good. API. Interesting. Insert fail, then we return. And this is unreachable. No duplicate found. Let's run it. 83445. Hooray! I think we're done. First one. I don't know why I got confused by that one. Let's look at it once more. So what I was doing was, from an empty set, I was checking if the current frequency is there. Okay. Then I was incrementing the current frequency and then inserting into our hash set. But why was that giving me incorrect answer though? Let's ask it again. I don't understand. Because it was in the set before updating it, this could cause you to miss the first update. Anyway, okay. Now let's do some code parsing. Okay, so let's see what we can do. Let me give you a rundown of what exactly we are doing here. So this is the language. Let me show you some sample programs which will make it maybe a bit clear. What are we doing? Where are our sample programs? Oh, I don't know where our sample programs are. Okay, let me open my Python project which has these sample.